Okay, Assalamualaikum. Okay, are you with me? Okay, so sorry for the uh, inconvenience conditions. So we continue again. We start again for chapter 1, electrostatic. So for this semester, the chapter 1 start with topic electrostatics, and there are contents for subtopics. So first, 1.1 is Coulomb's law, 1.2 is electric field, 1.3 is electric potential, and 1.4 charge in a uniform electric field. So for these topics cover for 2 hours. And for today, I will cover for subtopics 1.1 and 1.2. 1.1 is Coulomb's law and 1.2 is electric field for 1 hour. Okay, learning outcomes for this topic. At the end of this subtopic, students should be able to first state Coulomb's law. Coulomb's law, F is equal to Q1 Q2 over 4 pi epsilon naught R square, or K Q1 Q2 over R square. And then B, students should be able to sketch the electric force diagram and apply Coulomb's law for a system of point charge. Okay, this one for the first subtopics 1.1. Okay, what is Coulomb's law? Okay, Coulomb's law states that the electrostatic force means the force between two charges separated by a distance r is first inversely proportional to the square of the separation r between the two charges, and then directly proportional to the product of the magnitude of the charge Q1 and Q2. So, in conclusion, it can be written as F is equal to KQ1 Q2 over R square. So you can see, first time using this pen. So F means force. What is in this case we call electrostatic force F. So Coulomb's law state the electrostatic force F between two charge. So between two charge means charge Q1 and charge Q2. So is equal to F is equal to K Q1 Q2 over R square. R is the separation between two charge. So Coulomb's law state that F is equal to K Q1 Q2 over R square, or force, electrostatic force between two charge is directly proportional to the product of Q1 and Q2. Okay, product means the Q1 and Q2. Okay. And inversely proportional. Inversely proportional over R square means if the distance between two charge is increasing, the force will be decreasing. Okay. Sorry. Dia kena cakap Melayu kot, tak pupil. Okay, again. So for this Coulomb's law, we have the equation for Coulomb's law. F is equal to KQ1 Q2 over R square. So from this equation, we have the parameter. Okay, parameter K is a Coulomb constant. So the value of Coulomb constant is 9 times 10 power of 9 Newton per meter cube per Coulomb cube. Coulomb cube square. Sorry. Okay, asyik terputus ya Ana. Okay, never mind. So we continue. Okay, Q1 means the magnitude of charge Q1 and Q2 is the magnitude of charge Q2. And R is the separation distance between two charge. So, and then the value of K also can get from the equation 1 over 4 pi epsilon naught is equal to 9 power of 10 power of 9. Okay, so this is a equation for Coulomb's law and this is the parameter. Okay. Okay, for the subtopic 1.1b, students should be able to sketch the force between the diagram and apply the Coulomb's law for a system of point charge. Okay, again, we know that the force is the force. Force means the quantity physics that have magnitude and direction. So force have direction. So students should be able to know how to draw the direction of the force. So how to draw the direction of the force depends on the charge. Okay, so electrostatic force between two charges is attractive. Attractive if the charge are opposite sign. Mean if the first charge is negative charge, oh, sorry. So you can see if the charge is positive and negative, so the force must be attractive. Yeah. So this one is negative charge and positive charge. So the force is attractive. Attractive means F1 towards F21. F21 is towards to F12. This means attractive. Nah? And then if the charge is opposite, if the charge is the same sign, attractive force is repulsive force. So this one is positive. So positive. So repulsive force. Or the same charge means positive, negative and negative. So repulsive force. Okay. The notation of F12 denotes the force exerted on charge 1 by charge 2. And F21 is the force exerted on charge 2 by charge 1. So on charge 1 by charge 2. So the first mean on the first charge by second charge. Tak ada. Okay. Special. Okay. Again. Okay, since electric force obey Newton's third law, therefore the force F1 and F21 are equal in the magnitude but opposite in direction. So it can be written as F12 is equal to negative F21. So we have three type of problem to sketch the force diagram. Sketch the force diagram and calculate the resultant force on charge Q1. So when you get the question first, okay, this one is type 1 problem. So we have to know, find the words on charge Q1. So on charge Q1, so you find what is Q1. So Q1 is here. So draw the axis on Q1. Oh, okay, sorry, first time using this pad. Okay, so you have to draw the direction of the force. So on Q1 mean F1. So we have three charge, 1, 2, and we have 1, 3. So for charge Q1, so you have to draw the direction. So what is that? Sorry. Okay, so you can see charge Q1 is negative charge. Okay, first we have to draw the charge between force between F1 2. So you see the charge on Q1. Q1 is negative charge and Q2 is positive charge. So you can expect that the charge is to the right. Why to the right? Because the different charge. Different charge means the attractive each other. So this one is F12. Okay. Okay. And then for F13 means the charge Q1 negative, Q2 negative. So the direction of the force is to the left. Mean F13. Okay, so this one is the direction. I teach you the direction of the force. Nah? So this one F1, 2, and then here F1, 3. So first, students should be able, you must know the how to draw the direction of force. Okay, so first you have to know, you have to find the word on. So on charge what? Charge Q1. So at Q1, you just draw the axis. So to make sure for your reference to know the direction of the charge between 1, 2 and 1, 3. And then second, you have to know the direction of charge. So for 1, 2 means 1 is negative charge, 2 is positive charge. So the direction is to the right. Okay, and then for 1, 3, charge Q1 is negative and charge Q2 is negative. So the direction is to the left. Okay. Okay. Type 1 problem means the force in a straight. Okay, this one is the type 1 problem. So again, student must know how to draw the direction of the charge. Okay. So again, I show you how to draw the direction of the charge. Okay, Q1. So Q1, so first you read the question and you find the word on. So you must find the word on. So on Q1, so you have to draw the axis on Q1. Okay. Sorry. Okay. Q1. Okay. And then how to do the direction? You must see the sign of the charge. Okay, so Q1 is positive charge and Q2 is negative charge. So direction is to the right, F12. So for F1 is positive charge and FQ is negative charge. So direction is to the right. Okay. So this means the same direction. So F12 plus F13. Okay. So this skill student must know how to draw the direction of the force. Okay. Okay. This one is type 1 problem. Okay. Okay. Type 2 problems are when three charges are placed along the x-axis. Okay, this one we call x-axis. Okay. And then a charge charge A and charge B. Then three charges are placed along the x-axis. Charge A is equal to 18 nano coulomb charge placed at the origin. So first, when you get the question, you have to draw a diagram. So again, draw a diagram. So diagram. Then second, you have to write down the equation. Okay, so equation F is equal to K Q1 over Q2 over R square. And then P is the parameter or the value. So the value of charge A is 18 nanocoulomb and charge B is negative. So the sign of charge is very important. Why? Because we have to know the direction of the force and then placed at the 60 centimeter location where along the x-axis. At what x coordinates must positive charge C be placed in order to be equilibrium? Means we have the three charge, charge A and charge B, and then which coordinate to place the C. So to make sure that the charge must be equilibrium. Charge equilibrium means F CA is equal to F B C. This is the type 2 problems. So you can try this question and answer the question. Okay, and then okay. Type 3 problem is I show you the first type problem, how to solve the first type of problems. Okay. 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 This is the example for the question. Okay. Sketch the force diagram and calculate the resultant force on charge Q3 is 0 Newton. So first you have to find out the word on charge. Okay. So okay. So 3-point charge are firmly held on a straight line of 4 cm in length as shown in the figure below. So first, when you get the question, you have to draw the diagram. Okay. So you have to know how to draw a diagram. So you have charge Q1, Q2 and Q3. Okay. Then the question asks you to find the charge Q2. Find the resultant electric force acting on. So first, when you get the question, you have to find the word on. Okay, on what? On Q2. So on Q2, you have to draw the diagram on charge Q2. Okay. Okay, you can see, yeah. Okay, so you can see the direction of 2, 3 is to the right. Why to the right? Because Q2 is positive charge. So between 2 and 3, Q3 is negative charge. So the force is attractive force. So the direction is to the right. And then for Q1, the charge for Q1 is positive charge, and the charge for Q2 is positive charge. So the force is repelled. So the force is directed to the right. Okay. So again, now first you have to find the word on charge what? So for this case on charge Q2. And then second, you have to draw the force. How to draw the force? You have to know that the same sign is repel. And okay, so different charge will be attract. Okay. And then the force acting on Q1 to Q1 is repulsive force. Repulsive force because Q1 and Q2 have the same sign. Okay, Q1 and Q2 is positive sign. So the force is repulsive force. And the direction F21 to the right. Okay, first you have to know how to draw the direction of force. Okay. So the force acting on Q2 due to Q1 is attractive force because the Q2 and Q1 have the opposite direction. So therefore the direction of F23 also to the right. Okay, so this student have to know how to draw the direction of the force first. Okay, then you have to write down the equation. So the equation is F is equal to, okay, this one the general equation for Coulomb's law. F is equal to KQ1 Q2 over R square. So you have to put the parameter for Q1 and Q2 and the value of R. So in this case, K is equal to, K is constant, Q1 the value is okay, the value of Q2 and the distance between two charges. So you have to identify the value of R depends on the distance between Q1 and Q2. Okay, so you know that okay, you know that Q1 is positive charge, Q2 is positive charge, and Q3 is negative charge. Okay, Q3 negative charge. Okay, to substitute the value in a equation, you the value of the negative, don't put the value of negative. You just put all the positive value. Okay. Even though the value of Q3 is negative, you must put the sign of positive because F is the direction, F or force is a vector quantity. Vector quantity means have magnitude and direction. So the sign of positive and negative show the direction of the force, not the value of the force. So the sign of the charge is used to draw the direction of the force. Okay, so never put the negative sign into the equation. Okay. Okay. So, therefore, the resultant electric force acting on the charge Q is F is equal to F21 plus F23. So, how you get the positive? Okay, sorry. Keep. Oh, putih pada. Sekejap. Okay, so you get the value of F21. F21 is 11.25. Supaya hilang. Sekejap nah. Okay. Okay. Yang ni, yang mana ni? Hilang pula dah. Sana. Hilang pula dia punya ni. Okay. Sekejap nah. Okay. Hilang. Okay, so resultant force means F, resultant for F is equal to F121 plus F23. This is the equation for resultant. Resultant means plus. Okay, so for this case, the direction F21 is to the right. So direction is positive. So direction of 23 is positive. Why positive is because of the direction is to the right. So you have to sum F21 plus F23. Okay, this one. Okay, in case the direction is to the left, so you must put the sign, the negative sign. Okay, so the equation, general equation for resultant is F is equal to F12 plus F13. But if you want to put the value of F12 or F13, the value must be positive or negative. Positive means the direction of the F is to the right, and negative sign means the direction is to the left. So you have to identify the direction of the force to make sure you put the correct sign, means positive or negative sign in the equation. So this one, the first type problem of Coulomb's law. And then we also have the type 3 problems. Okay, type 1 problems means in a x axis or in a y axis means in one direction. So for 3 types problems means the force in 2 dimension. Okay, for example this one. Okay. So we have Q1 and Q2. Where is Q2? So again, you have to make a revision of chapter 4 about the force. So if the force, if the charge not lie on x-axis or y-axis, we have to draw the x component and y component. So for okay. Okay. This one type 3 problems means okay. So when you get the question, first again you have to find the word on. Okay. So on Q1. So Q1, so you have to draw the so first you have to find the keyword Q2. Q2. Okay, never mind. Wow, what Q you have to find out the keyword for on. So for this question, state on Q2. So on Q2 you have to draw the x axis and y axis. Why? Because force is a vector quantity, have a direction. So we have to draw the direction of the force. So for this case, we have Q1, Q2, Q4. Okay, I show you how to draw the direction, right? Okay, Q1 is positive charge, Q2 positive charge. So the direction is to to the to the right. Why to the right? Because same charge, positive and positive repulsive force. Repulsive means to the right. Okay. So for Q4 negative 1. So Q4 not lie on x-axis or y-axis. So you have to draw the Q for y and so you will see the positive and negative. So positive and negative means the direction is here. So you have to draw the hilang mana pula dah. Okay, means sorry for inconvenience. Okay. Okay, again I show you how to draw the force. Okay, for this question on Q4. So you have to draw on Q4, you have to draw the axis y and x, and then Q4 is negative. This one is Q3. I think Q3. Q3 is negative, so direction is to the right. Ni F4 3. So for F two positive and negative, so direction F 4 2. Why direction is outward? Because attractive force. Okay, for the Q1 and Q3 is different signs. So attractive force. Susah juga. Okay. So you know that the direction in lie between X and Y. So you have to resolve. So Q1 you have F41X and F41Y. Okay. So for further solution, you can discuss in tutorial class. So next, I want to we proceed to the second subtopic is electric field. Okay, electric field. The new outcomes for this topic is at the end of this subtopic, you should be able to define and use electric field strength. So electric field strength symbol E is equal to F over Q naught. Sketch the electric field lines of isolated point charge, two charge and uniformly charged parallel plates, and see determine electric field strength E for a system of charge. Okay, again, electric field also the have direction. Okay, so but different from the force. Force direction can be identified because of the sign of charge, mean positive charge or negative charge. But for the electric force, direction of force define the electric force acting on small test charge that is placed in the electric field region divided by the charge Q naught of the test charge. So E is equal to F over Q naught. So E is a vector quantity and the unit is Newton per coulomb. So direction of the E depends on the charge. Okay. Electric field pattern can be represented by electric field line which is drawn pointing into the direction of the E vector at any point. So these lines do not intersect each other and the number of lines determine the strength of the electric field. Thus, E is large when the field lines are close together and small when they are far apart. Okay, so this is how to draw the direction of the E. So direction of E for positive point charge is outward. Okay, you can see the positive charge, so the direction is outward from the charge in all direction. Okay, for positive charge, direction of E for negative point charge is toward to the charge. Okay, you can see the negative charge is the direction if toward to the charge. So when the positive charge, the direction is outward to the charge. Okay. Okay, this is how to draw the direction of E. Okay. So the strength of E will decrease when the distance from the charge is increased. Okay, you can see how to draw the direction of E. So, okay. Okay, the figure below is the electric field lines patterns for two equal and opposite point charge. Okay, this is how to draw the direction of electric charge. Okay, so okay. Okay, according to Coulomb's law, F is equal to Q naught 1 over R square. From the definition, E is equal to F over Q naught. So, by substitute the question, we have the value of E is equal to KQ over R square. Okay. So, E inversely proportional to R square means if the value of E will be increasing when R is decreasing. So, the relationship between E and R can be shown in the graph below. Okay, graph E against R. So, you can see the relationship between E and R is inversely proportional. Means when the distance between the distance R is increasing, the E will be decreasing. Okay. So example, how to determine the electric field strength at a point X, a distance of 20 cm from a point charge Q. Okay, the value of Q is positive 8 microcoulomb. So how to find the value of E? Okay. Okay. Okay, again, these are very important. Students should know that for positive charge, the direction of electric force same the electric field. For negative charge, the direction of electric force is opposite to the electric field. Okay. So type 1 problem, we have 2-point charge, positive 2 microcoulomb and negative 4 microcoulomb are separated by 10 cm. So determine the magnitude and direction of the electric field at a point midway between the charge. So, okay, this example how to solve the problem about the electric charge. Okay, electric charge means Q1 produce electric charge, Q2 produce electric charge, but the direction of charge depends on the type of charge. So for Q1, we know that Q1 is positive charge. So positive charge means the direction is toward or inward. Okay, yes. Okay. So this one is positive charge. Positive means the direction is outward and okay. So you have okay again. I repeat again. Say okay. Okay. 2-point charge Q1 positive and Q2 negative. So Q1 is positive. Q2 is negative. Okay, are separated by a distance 0.3 meter. So distance between Q1 and Q2 is 0.3 meter. Between each other as assigned figure below. Determine the resultant E produced by these two charge at point P. So for solve the problem about the electric charge, you have to find the word at. At what? At point P. So at point P, you have to draw the axis. Different with the force. Force, you have to find the word on charge. But for E, you have to find the word at point P. So at point P, you have to draw the axis. So axis Y axis and x-axis. And then you have to draw the direction of E. So for Q1, Q1 is positive charge. So direction you have to draw outward. So this one is E1. So Q1 produce E1. And then direction of Q2, okay, Q2 you know, Q2 is negative. So negative, the direction is inward. So at this point you have to draw. Okay, so here is E2. Okay, get it? Okay, and then you have to know the angle between. Okay, because of E2 not lie on x-axis and y-axis, you have to resolve E2 for E2x and E2y. Okay, so this is you have to make a revision for chapter 4, force, chapter vector. This is vector. So when the E2 not lie on x-axis and y-axis, you have to resolve this into E2x and E2y. Then you okay. Okay. So and then you have to find the angle between the E. Okay, so I think a lot of trouble for this lecture, but never mind, as long as we can proceed the chapter subtopic 1.1 and 1.2. Okay, for further inquiry, you can refer to your tutor, and then you can ask the question. Okay. Okay. So okay, settle for today. Okay, bye bye.